want to give you a bit of a story and kind of focus around my adoption of Rust, why I've done it, and I'm going to try and, similar to the presentation this morning, try and adjust this a little bit to the level of the room. We'll see how we get on with that. But to give you a bit of background on myself and my kind of angle to coming to this, so I have been a software developer and consultant for about 10 years now, independently working on generally custom measurement systems for scientists and engineers. So just to give you a bit of a sense of the background here, it's a little different from a lot of people I've spoken to in that it tends to be low volume, very specific systems. As an example on the right here is, this was like a one-off test system for a civil engineering department at a university. The kind of light square in the middle is their concrete test block, and they would put thousands of kilonewtons, if I can remember the numbers right, throughout cycling that for several days to see what happens. On the left is a bit more where I've ended up, which is a bit more helping people to get products off the ground. So on the left is a product by a company called Quantum Detectors, who work with spin-out technologies from some of the UK's like particle detector ecosystem and being able to commercialize those. And I want to give that a bit of context because that'll probably color some of the decisions and some of my decision points around Rust and why I've got here. So I've actually been, for most of my career, a LabVIEW developer. How many people have heard of LabVIEW in the room? That's more than I expected. So I actually started with NI, who created LabVIEW out of university, spent 5 years there, and then started out as a LabVIEW developer independently. And if you haven't seen LabVIEW, it seems most of you have, the code is on the right there. So it's a visual programming language based on a data flow idea. So the idea is each block has wires going in and out. That's your data. And the block will execute when all of its input wires are available. And there's a few things more recently that come around this concept, but I think the interesting thing with LabVIEW is this has been around since the late 80s. It actually compiles down to x86, so it's actually very powerful, a lot more than a lot of people give it credit for. But over time, as I've kind of been diverging away from the core of LabVIEW, which tends to be test systems, I found a few gaps. And the big one being kind of software engineering tools. So it's worth saying, why did I use LabVIEW in the first place? To give you an idea of what I've been looking for in Rust. So LabVIEW gave me a single tool for desktop, real-time controllers, and FPGAs. And it has a built-in user interface, which has made Rust feel a little foreign on that side. As I've come to Rust, I've had to actually make decisions. It's highly productive. And that's important for me because I work by myself. I don't have a large team of developers. I have to take ownership for large parts of these products, and so I need a productive tool. And all of that adds up to, hopefully, fast development at low cost and time with restricted resources, i.e. me. If I don't have the ability to do every part of the system, I have to hire in other people, and it gets more complicated. And hopefully you can see there's a huge number of similarities here with Rust, and that's kind of why Rust appealed to me. I sort of had an inkling I should be looking at C++ for a little while, and I could never quite jump into it. It just felt like the barrier to entry was too high, whereas Rust gives me most of this list, but with some added capabilities. And so, yeah, the reason I was looking for change was, ultimately, it's a proprietary language. It follows the interest of the vendor. So as I wanted to target different systems, for example, that became more difficult. And the software engineering was the big problem. There are tools in LabVIEW for a lot of these things. They tend to not be very mature. I describe it as suffering from the graphical tax. You know, every text-based language can kind of leverage tooling from each other. You know, simple things like git diffs, right, will work across different languages. With LabVIEW, everything like that has to be built from scratch. And so, yeah, so I've adopted Rust pretty fully at this stage, and I wanted to kind of run through a kind of, like somebody referenced earlier, sort of came for the memory safety, but actually one of the things that's really attracted me is the tooling and what that's enabled me to do. So just to gauge this a little bit, I guess, who is familiar with Clippy? Yeah, that's what I thought. So originally I set this a bit lower. So I'm going to slightly adjust how I run through this, but I've got a few bits to fill it out. But I wanted to highlight a few things, and I guess it almost fits in with what we've been discussing just now as well, is that how this has helped me with adoption into customers as well. So the first thing is the installation process. I've kind of tried to work with tools in the past where they're very Linux-focused. So you get all these instructions on how to tie it into Linux, and Windows was always a little bit clunkier. Recently, I have not convinced, they were quite open to using Rust on a new project with a customer, and the fact that they could just go run Rust up, install the toolchain, run cargo run, and everything was there and running on their systems was a huge boost, and I think helped them get over that kind of buyer's remorse of, was this the right choice? So yeah, so the latest project I've been working on is one of the largest projects I've taken on in Rust. And so what I've done here, I can't show the actual project, but I've kind of created a really cut down basic project that shows some of the flow of tools that I've been using as part of that. And the first one is the testing. LabVIEW has a few test environments, but they're pretty rough around the edges, shall we say. So again, the fact that I can come in, hit cargo test, and it's going to run all those tests is fantastic. I've recently discovered and been working with cargo next test, or I guess next test, which if you haven't seen, takes exactly the same test framework, and it's going to run hopefully faster. The idea is every test run in parallel. It's got a load of other stuff I need to play with and really adopt in. I think it's got better reporting, for example. But I think one of the really nice things with this is it just highlights how the kind of core Rust project has got the essence of it, if you like. And then the community, or the ecosystem is the word I was aiming to use there, is able to build upon that really quickly. The other one is when I first came to Rust, I was quite interested in getting test coverage. There's not a good solution for test coverage in LabVIEW. I don't believe that you should be tracking that all the time. I don't think that's a good goal, let's put it that way. But I also like to have access to it every now and again so I can just look for other gaps. Am I hitting about the right levels? And a couple of years ago, this was pretty ropey on Windows, especially. Now, I've been working with the LLVM curve tool, which I now feel like I'm missing a hyphen, aren't I? And suddenly, again, without too much extra work or installation, I have that tooling available as well. So that's the testing. The other thing I've really, actually, and I should again emphasize that if you are going into some more, let me think of the polite way to say it, less sophisticated software industries, this was one thing I really undersold when I was selling Rust. They had research software that had been written at the university, and I just, we'll just use good practices and we'll build the software. And then I came in and demoed them the software and said, we'll run the tests. We made a change. It was like, well, what was that? It's like, we've just rerun the test suite. So you can do that? So it's these little things that create really low friction for Rust. And obviously these things are available in other languages as well, but on another project we had to pull in some C code. I'm very comfortable with TDD kind of flows, so I hooked it up to Google Test to be able to test that. Every time I pick up that project again, I have to relink Google Test. This is my inexperience, not Google Test's fault, perhaps, but it's just another layer of friction. Whereas in Rust, I know I can give them the GitHub to this, they can run it, say, right, run cargo test, the test will run. Clippy is the other thing that is a big thing for me. And this is why I wanted to ask this. I didn't want to try and give too much introduction here. One of my big fears is these systems are supposed to run 24/7. And in LabVIEW, you don't really get the panic situation. It can, but you're really long past things going wrong once it gets there. So I'm a little bit paranoid about this. So with Clippy, what I've done, and this is a fairly recent feature, I think, I'm configuring the lints in the workspace. I want to find a way to spread this to all my projects. I don't think such a thing exists right now, or there's something similar that I need to investigate. But this allows me to go with a level of certainty again to my customers as to the quality of the software, and automate those checks throughout. So I'm still kind of playing with the exact set here, but for example, the indexing slicing has caught me out before, where we had external data from an external tool. I assumed everything should be the same length. Assumption is always the key to these things, and they weren't. And I suddenly realized I had to worry about panics now. So I'm trying to deny that in a lot of the code to kind of avoid those situations again. Not always trivial, but I basically try and use iterators whenever I can, and that seems to solve most problems. So I don't know how many people come across the just command runner, I think is what it calls it. It's pretty cool. I again, come from a place where we don't have these kind of tools. So it may be more basic to others. It's not Rust specific, but it's written in Rust, so I like it because you can just cargo install it if you've got the Rust tool chain. And so I've been using this to kind of build out the tools, and again, to be able to hand them to customers and be able to say, right, run just lint, and it's going to run all the checks on the software that you need, or just test. And so that's been hugely valuable. So, and cargo deny, I think there was a reference to the kind of upcoming legislation all across the world, but I think the European Cyber Resiliency Act, is it, that's coming in soon, needs you to be more aware of what's going on with your dependencies. So again, built into the Rust project, this is the kind of thing that's been really easy to promote to customers, is we can use tools like cargo deny that will tell us if there is a vulnerability reported in a crate. Another handy one for them, because it's a commercial tool, is we can also specify what licenses you can take on. So if you don't want to risk ending up with something like GPL code in your product, we can kind of we can allow certain licenses to exist within the cargo deny tool as well. So all of this is, from my perspective, working as a single-man team, a superpower. I wouldn't have the ability to manually run through all of this on the regularity that I can by using these automated tools in Rust. Now, this is where I have to check that I've covered what I was planning to. Kind of as was talked about earlier with C++, of course, you can't always leave everything behind. There's always going to be places where we need to integrate back into things. And actually, that's a bit of a superpower of LabVIEW. It has really good integration with a lot of different software ecosystems. The big advantage for us is it can compile out to DLLs that can be called, or shared libraries that can be called. So we can build FFI tools to interface that into Rust. And I've been able to create a crate to do the reverse, to handle LabVIEW types in Rust for pushing back and forth with LabVIEW. I'd actually forgotten this bit as well before someone mentioned it this morning. Cross-compilation. Again, something that came in LabVIEW, and I kind of thought I might have to leave behind, is that ability to hit NI's embedded Linux targets. Actually, with Rust, it took, a morning of kind of tinkering, finding the right incantations for cargo, and I'm able to build things in Rust, cross-compile that, and still work with the same hardware that we had before. But no doubt there's effort in kind of combining these ecosystems, and there's still libraries I'd love to wrap to work between the kind of hardware and with Rust. But again, there's really good kind of existing material to work from for that. And I'm going to give away that I used to work with a proprietary language, because I realized I call these community tools, and I prefer the term ecosystem because Rust is a community tool in itself. But obviously, LabVIEW, we kind of have this distinction between the proprietary tool and tools developed by the community. And one thing I was trying to think as I prepared for this presentation is, where did I learn about these? Obviously, a bunch of it ships with Rust. And it's worth calling out that there's a lot of places where you can kind of discover these tools. I think, everyone's involved in online groups nowadays, so the forums, Discords, books. I wanted to call out Zero to Production. I'd kind of done a bit of Rust, and I wanted to try and write a web backend. And Zero to Production is a book by Luca Palmieri. I think it describes itself as opinionated, which is great for me getting started, because it just said, here's a good tool for this, here's a good tool for this. There's probably others, but it really helped me to get going quickly and produce a higher quality of software at the end of the day, better tested than I would have otherwise. And I realize the other one is just going through GitHub CI flows. So when I'm taking on a dependency, I try to go to GitHub, look at the activity, and one of the things I always look at is, okay, what CI have they got set up here? From my point of view, that's a bit of a quality marker. Are they regularly testing this code? But I realized some of these, I think Next Test is one that I've slowly absorbed through that. I've kind of just seen it so many times, looking through GitHub CI flows, you get to a point, it's like, right, I should probably actually investigate this a bit further. So from my perspective, it's been a big success. I think compared to LabVIEW and compared to other languages, I'm spending way less time managing tools and a lot more time building software, which isn't that what we all want. And the thing that I've really reflected on is I've ended up building a better quality of software, because instead of fighting the tools, I'm able to adopt them more readily. I'm doing more advanced testing automatically than I'd have ever done before. The linters, being able to have some of that automated analysis, like I say, it just wouldn't be practical for me to do that manually at the kind of cadence that these tools require. Oh, these customers require, sorry. And as I say, exceeding people's expectations in some of these industrial settings has been really powerful. With this existing customer, there was a question mark over Rust, but being able to immediately show them progress, being able to show them the quality of the output has really stood me well. And as I say, as a single developer, Rust feels like it gives me a bit of a superpower compared to where I was before. And that's all I have. Any questions?
Thank you, James. We have a few questions.
Thanks a lot for your presentation. Do you have a GitHub up for your demo project? Because it looks like it collects a lot of opinionated settings for projects that might be interesting for many of us.
Yes. So yeah, actually, I meant to push it up to GitHub before this, so it has some, I can have a path. But yeah, exactly that. It's kind of trying to just pull out a base set. The other thing I didn't say is I jump from between projects a lot. So I really need like a base set to just get going and not have to remake these decisions every time. So yeah, I'm happy to share that and push that up as well. And yeah, I meant to reference to the testing. It's like, I'm happy for Rust to make good decisions for me and the tools, and then just tweak them as I need to.
We do have another coffee break coming up after the next talk, so you can always share the GitHub information with everyone then.
Hi, great talk, thanks. As a single developer, I'm sort of in the same boat as you, not having colleagues to bounce ideas off. How do you discover what's the best tool to use given, what's out there? Is there a trick you use? Are there people that you ask? Is there some community that you tap into?
Yeah, so a lot of it is just online communities. So I've actually been in Tim's Patreon, I was going to say Slack, Discord, and that's been really helpful. So actually one I meant to call out and didn't was Cargo Sweep. That was a quick post into Discord saying, my files are getting huge, I must be missing something, there must be a trick to this, and getting very fast responses there. So It's a bit of a corpus to build. A year ago, I didn't have all of this, and it's kind of just been trying to slowly add them, either identifying a problem or noticing a pattern, and pulling them out like that, really. I meant to say as well, most of my talk is condensed into these handy beer mats that are lying around from Ferrous Systems. So that's probably a good place to start as well. And there's a couple on there. I'm like, I should probably go and have a look at those as well. So I wish I could say there's a better answer other than just trying to absorb as much as I can as I go and kind of mark that as, okay, I want to look at this. And I do try and go through a bit of a test period as well. I go, okay, I'm going to, try this on a minor project. I did the same with Rust, really. Very often it's a case of, okay, well, initially it was, I've written this in LabVIEW, now let's write it in Rust and see what that looks like for just a small bit. Then it's, okay, not ready to do a full project in this, but maybe I need a device simulator, so I'll write that in Rust and still have LabVIEW at the core. And then it's kind of the same with tools. It's like, okay, it's like with the coverage tool. Right now I'm kind of at the early stages of, okay, I have that command handy. I haven't integrated it into the CI yet or presented that in any way, but perhaps I will do so once I'm kind of comfortable with it. So I try and baby step into, work with a lot of conservative companies. I really want to be able to justify my choices. So I do try and kind of baby step these in one bit at a time. Also just avoiding getting overwhelmed myself with so much to learn.
Okay, we have 2 more questions, one here and then one there, or maybe 3.
I do have a love and hate relationship with visual programming languages. I find they often do not scale, or at least I haven't found one that scales. And also point and click is really not the way I like to program. But either way, I do think they have an appeal. And so I'm referring to this LabVIEW slide that you showed. And I just wondered, have you considered building your own LabVIEW-like visual programming language in Rust?
Not heavily, because I quite like Rust, to be perfectly honest with you. There have been people looking at that and going, okay, how can we kind of essentially modernize what's under the hood and build this visual tool on top? But honestly, as I say, I've come to the conclusion that while I think the visual paradigm itself works, I think you're always going to be behind in the tooling. There's just a lot more work to be done. Whereas with a text-based language, you're able to leverage the work of the entire community a lot more. But it would be interesting, and I think there probably are efforts to do something like that somewhere. I just haven't had enough justification to look myself.
Okay, over here.
So thank you a lot for the talk. Really interesting, the tools that you share. I wanted to share a comment on one of the tools,
sure,
or maybe get your perspective on it. So you mentioned cargo deny. We are also using it for license checking, for vulnerability alerting. I think it's quite handy, though when you have a large workspace, it needs some aftercare, because you will have workspace members that are not in your production deployment. So I don't know, it can happen that you get a ticket from your legal department saying, hey, there's something wrong in your software, and then you figure out, wait, that's not going to the client, that's not in the deployment. And also, like, when you're investigating this kind of issues, I remember we had some super urgent security issue that showed up on my desk, like, you have to check that. We figured out, okay, it's not actually affecting us, just like some dependency pulls in a feature due to feature unification in a workspace, and then it looks like it. So for this, just a shout out, I think using cargo tree, learning a bit with the parameters helps a lot then to figure out, okay, what is actually going into your software and what just shows up in the log file in case you out of nowhere decide to build for a different target, but you actually never do that.
That sounds really interesting. What did you say you're using for that?
So the tool is cargo tree, and I think it comes with cargo itself. You don't need to add it to the installation, so it's already in there, and it gives you a tree of how your dependencies tie in, and you can reverse it. You can see, like, okay, how does my security affect the dependency? Where does it come in? You can show which features are activated on which other dependencies, and But thanks for sharing them.
No worries. No, it's a good point, and I have actually exactly hit that on another project where, like, especially with like these simulators, it's like, we don't really care what's in there, frankly. As long as it works enough to run the test, that's great. And so, I haven't had a good answer to that. I haven't played too much. I think maybe at that level, the answer is you need some kind of tool, because you need a record of why you're ignoring it somewhere. And don't know that these tools will probably ever quite provide that. I sort of played with SemGrep. Is one of the few kind of wider security tools that supports Rust. So on another project, I've got that, and then you can mark them as, we're ignoring this because X, Y, Z. But I haven't played with that a huge amount. I think that's probably normally going to be the answer for something like that. And then, yeah, figuring out how to ignore it in the tool itself, which I imagine is an option there, but I've not done it.
All right, this is going to be our last question for today, for this talk.
Thank you. It's actually not a question, more like a comment or a praise. But first, I'd like to address the Anatol's temptation for visual languages. The major question to answer is how to merge them. And that's the biggest problem to solve first, before you even think about it. Now, then, about this presentation, thank you very much. I think this is a great example of what we were talking earlier about sending a message out to the world. So you've shown us a very practical example where you really benefited from the Rust, not only as a, this language gives me safety, but a lot of other things that comes out of the box because you actually decided to do it right way.
Yeah.
So I really love it.
Thank you very much.
Great. Well, thank you so much, James, for sharing that knowledge and hopefully giving some inspiration and ideas of what you can do with Rust tooling. So thank you.
Lovely. Thank you.